boy rolls a stone in a horizontal circle of radius 2 meters and height 4.9 meters above the level ground. Okay, so something like this, 4.9 meters above the ground. So who rolls a stone horizontally with circular motion. The radius is 2 meters. Okay. So at some point, the string breaks. So when the string breaks, the stone will be projected out along the tangential direction, right? So it will have some, it's a horizontal projection. The projectile motion like that. Okay, the landing point is 10 meters away from the leasing point. So we want to, okay, if you look at it, we want to find the magnitude of the centripetal acceleration. We want to find the period of the motion and how many revolutions per minute for the motion. So, again, okay. When you look at this question, centripetal acceleration, period, and what we asked for last question, how many revolutions per minute? Actually, you can see we're asking calculating 60 divided by period t, right? If you know the period. We ask you how many revolutions per minute. 1 minute equals to 60 seconds. So we'll ask you how many revolutions you are going to have for 60 seconds. Each revolution the time for each revolution is the period. So 60, the total time divided time for each period, or for each revolution, give you the number of revolutions, right? So you can see part C actually depends on part B, the period. And both of them can see depends on which quantity? Velocity of the circular motion. Okay. So T actually comes from 2 pi r over v. This is of course v squared over r. R is 2 meters. So once you know the velocity of the circular motion, you get all these quantities. Okay. So even you don't know how to calculate the velocity, if you write down these equations, tell me you know they can be calculated from the velocity, and you get some partial points. Some of you did that. Okay. And now let's look at how can we find out the speed or the velocity of the circular motion. We have to look at the projectile motion. It breaks. After it breaks, it will be projected with that velocity. So the velocity we are trying to find here, v, is actually the initial velocity of the projectile motion, right? So we try to find the initial velocity of the projectile motion. It will be the velocity we're going to use here, right? Can we find the initial velocity from the given numbers, the 4.9 and 10? Yes, we do. If you write down the known quantities along x direction and y direction, along x direction, v naught x is the quantity we want to find, right? That's a horizontal projectile motion, so v naught y equals to 0. And for any projectile motion, we know ax equals to 0, ay equals to 9.8. Okay? For this problem, it's better to choose 9.8 because this height is 4.9. And then you know delta x equals to 10 meter per second, and delta y equals to 4.9 meter. So of course you can see what you are going to do. You can looking at the y direction and try to calculate the traveling time t, and put t here to get the initial velocity, right? And then you can calculate these. So from here, what you are going to do is delta y equals to v naught yt plus 1 half a yt squared. This will give you time t. I think it's 1 second, right? Okay, so you have that, so that repeats the calculation. And then along x direction, you have delta x equals to v naught xt plus 1 half a xt. Okay, x equals 0, so this calculation is very simple. It will give you what is the initial velocity? 10 meters per second. Okay. Now you put this 10 meters per second to here and to here, you will get centripetal acceleration and the period. Once you have period, you get how many revolutions per minute, right? Okay. So I would say this is in fact, if you can decouple it into two parts, circular motion and projectile motion, it's a straightforward problem. Okay, question?
Is that t equals 2 pi r?
Yeah, 2 pi r over v. Okay, the period 2 pi r over v. Okay, any other question?
So AC will be 2.
What's AC?
I mean, 5.
AC, let's see, 10 meters squared,
Oh,
50.
50.
Right?
Okay.
Okay.